So nums array, first index, so 0 index is empty. This is always empty. So nums 2, 3, 1, 1, 4. Return true if you can reach the last index. So if I can reach this index. One way to do this is doing actual step at a time. So this one, we can reach it. If we couldn't reach from this point, we could have done was try all the steps. Okay, so you can jump. You are initially positioned index, first index. Each element, yeah, your maximum jump length. Maximum jump length means you can also go one step, and then from here, from 3, you can either go 1, 2, 3. So as long as I can find out whether I can reach the last index, I can return true. If we think about this from coming from the end of the array to the first one, let's say we are coming from here. We can try to check next one and see if we can reach the current index. So because it is 1, we can reach. So maybe I can use this different example. I'll use this example first. And then from 1, I can try to check my previous index. Yes, I can reach this one. I can reach. So let me actually change the example here because this is not very helpful example. Let's say we are given 2, 1, 3, 1, 4, 6. Let me say 2. Okay. From the end, check if previous index 2 can reach my current index. Yes. Then my pointer, initially the pointer is here. Next iteration, the pointer is over here. I check previous one. Can I reach? Am I looking for a first index that can reach? Yeah, because we are just interested in returning true or false on whether we can reach. What if these were 4, 0, 0? Then I'm gonna check while my pointer is at this index. I need to check, is my previous index reachable from, or is my current index reachable from previous index? Nope. So this is not right. This cannot reach either. And then since I get here 4, I can actually jump from 4 to 2. So then my pointer goes here, check previous one, and then now I'm at the first index, so I can say true. So the logic will be one looping from end of the array. First, find first index that can reach current index. And then update current index to be index from number 1. And then we keep going until keep looping until we reach index 1. Yeah. When loop is over, if current index is not 1, then we can return false. So the time complexity will be of n. Because this is the first indexed array, or one indexed array, the last element will be in the length. Yeah, we don't have to do length minus 1 because the length will be 6 for example. In this example 1, the length will be 6, or length will be 5. When you are initially positioned at the array. Oh, okay. So I misunderstood with the first index. So I thought this was one indexed array where all the elements are starting from 1. But looks like it's just mentioning it's at the very beginning. Okay. Then we can simply loop doing this, -1, -1, -1. We are going to find first index. That means we need to define current index to be the last one. And then I need to start from the second from the last. Does that, yeah, second from the last. And then if the current index, or the index I'm in right now, plus the value of that index is actually larger than or equal to the current index, that means I can reach current index from this I position. Then I can update I can check if current index is actually 0. I can return true. Otherwise, keep looping. So we are updating current index to the I. Yeah, once this is all done, if current index, well, we don't even need to check current index, because if we were able to reach the first index, then we will eventually get to this return true part. So the moment we exit out of this for loop, or if the moment this for loop ends, we know we couldn't reach the first index, so we can return false. Okay, let's try this out. Yep. Oh, okay. So I didn't check the number of length can be 1. Yes, so it's always, if there is just one element, we can just return 1. Or return true.